Arborist Podcast, Domain 2, Episode 1, Soils and Water, What is Soil and Why it Matters to Trees. Welcome back to the Arborist Podcast. This podcast is designed to help you study for the ISA Arborist Certification exam by breaking complex topics into clear, easy-to-follow episodes. As always, this podcast is not affiliated with or endorsed by the International Society of Arboriculture. It's an independent educational resource created to support arborists preparing for the certification exam. In Domain 1, we focused on tree biology and how trees function as living organisms. In this domain, we shift our attention below ground. Today's episode is about soil, what soil actually is and why it matters so much to tree health. Why soil is so important. Soil is more than just dirt. For trees, soil is the environment where roots live, grow, and function. Every aspect of tree health, from water uptake to stability to nutrient availability, is influenced by soil conditions. If soil conditions are poor, even the healthiest tree species will struggle. This is why the ISA exam places strong emphasis on soils. Arborists don't just manage trees, they manage the environment trees grow in. What soil actually is? Soil is a mixture of four main components: mineral particles, organic matter, water, and air. Mineral particles come from weathered rock and make up the bulk of the soil. Organic matter comes from decomposed plant and animal material. Water and air fill the spaces between particles. The balance between these components determines whether soil supports healthy root growth or restricts it. Soil is a living system, not a static material. Soil as a root environment. Roots do not just need nutrients, they need oxygen, they need water, they need space. Roots respire just like other living tissues. Without oxygen, roots cannot function properly. This is why poorly drained or compacted soils are so damaging. Healthy soil provides enough pore space to allow both air and water to move freely. When this balance is disrupted, root growth slows, stress increases, and decline often follows. Soil and water. Relationship water and soil is held in the spaces between particles. Some water drains freely through the soil, while some is held tightly to soil particles. Only a portion of soil water is actually available to roots. This is a key exam concept. Too much water can displace oxygen and suffocate roots. Too little water leads to drought stress. Understanding how soil holds and releases water helps arborists make better decisions about irrigation, drainage, and site management. Soil and nutrient availability. Nutrients do not exist independently of soil. Soil texture, organic matter, and biological activity all influence how nutrients are stored and made available to roots. Healthy soils support beneficial microorganisms that help cycle nutrients into forms trees can use. Poor soils often limit nutrient availability, even when fertilizers are applied. This is why fertilization alone does not fix soil problems. The ISA exam expects you to understand this relationship. Urban soils versus natural soils. Many arborists work in urban environments. Urban soils are often compacted, disturbed, layered, or contaminated. They may lack organic matter and biological activity. These conditions create chronic stress for trees. Understanding soil limitations helps arborists set realistic expectations and choose appropriate management strategies rather than assuming all problems are above ground. Why arborists must think. Below ground, soil problems often show up as canopy symptoms, small leaves, dieback, poor growth, decline, but the cause is frequently below ground. Effective arborists look past symptoms and evaluate soil conditions, root space, moisture, and aeration before making recommendations. This mindset is critical for both the exam and real-world practice. Let's recap the key points. Soil is a complex living system made up of minerals, organic matter, water, and air. It provides the environment roots need to function. Healthy soil balances oxygen, water, and space, Poor soil conditions limit root growth and directly affect tree health. Understanding soil is essential to understanding trees. In the next episode, we'll take a closer look at soil texture, structure, and pore space, and explain how these properties influence drainage, aeration, and root growth. Thanks for listening to the Arborist Podcast. Let's keep building your arborist knowledge one domain at a time. Arborist Podcast, Domain 2, Episode 2, Soil Texture, Structure, and Pore Space, How Soil Physical Properties Affect Trees. Welcome back to the Arborist Podcast. This podcast is designed to help you study for the ISA Arborist Certification Exam by breaking down complex topics into clear, practical explanations. As always, this podcast is not affiliated with or endorsed by the International Society of Arboriculture. It's an independent educational resource created to support arborists preparing for the certification exam. In the last episode, we talked about what soil is and why it matters so much to tree health. Today, we're going deeper into soil physical properties by focusing on soil texture, soil structure, and pore space. These concepts explain why some soils drain well, others stay saturated, and why roots struggle in compacted sites. Why soil physical properties matter. Soil texture, structure, and pore space determine how air and water move through soil. They directly influence either root growth, oxygen availability, water drainage and retention, nutrient movement. From an exam perspective, these concepts come up frequently because they explain many real-world tree problems. If you understand these physical properties, soil behavior becomes predictable instead of confusing. Soil texture explained. Soil texture refers to the relative proportions of sand, silt, and clay in the soil. These particles differ mainly in size. Sand particles are the largest, silt particles are medium-sized, clay particles are the smallest. Texture is a permanent soil property. It does not change unless soil is physically removed or replaced. This is an important exam point. Characteristics of sand, silt, and clay. Sandy soils have large particles and large pore spaces. They drain quickly, hold little water, and often dry out fast. Oxygen is usually plentiful, but water and nutrients may be limited. Clay soils have very small particles and very small pore spaces. They hold water tightly, drain slowly, and can easily become poorly aerated. When compacted, clay soils are especially restrictive to roots. Silt soils fall between sand and clay and often have good water holding capacity but can compact easily. Most soils are mixtures of these particles called loams. What is soil structure? Soil structure refers to how individual soil particles are grouped together into aggregates. Good soil structure creates stable aggregates with spaces between them. These spaces allow water and air to move through the soil and provide room for root growth. Unlike texture, soil structure can be improved or destroyed through management. This distinction is critical for arborists. Soil structure and root growth. Well-structured soils allow roots to grow easily between aggregates. Poorly structured soils, especially those that are compacted or crusted, restrict root penetration and reduce oxygen availability. Urban activities such as foot traffic, vehicles, and construction often destroy soil structure. Once structure is lost, roots must expend more energy to grow, leading to stress and reduced vigor. Understanding soil pore space. Pore space is the portion of soil volume not occupied by solid particles. Pores can be filled with either air or water. Large pores, called macropores, allow air movement and drainage. Small pores, called micropores, hold water that roots can access. Healthy soil contains a balance of both types. Compaction and pore space loss. Compaction reduces pore space by pressing soil particles closer together. This reduces macropores first, which limits oxygen movement and water infiltration. As pore space decreases, root respiration becomes restricted, even if the soil contains water. This explains why compacted soils often lead to decline even when irrigation is adequate. How texture, structure, and pore space work together. Texture influences how soil behaves naturally. Structure determines how well that soil functions. Pore space determines whether roots can breathe and access water. A clay soil with good structure can support healthy trees. A sandy soil with poor structure can struggle. The ISA exam expects you to understand these interactions, not just definitions. Practical arborist applications. Understanding these concepts helps arborists diagnose soil-related stress, recommend aeration or soil remediation, choose appropriate tree species, set realistic expectations for tree performance. When trees show stress symptoms, soil physical conditions should always be considered as part of the diagnosis. Let's recap the key points. Soil texture describes the proportion of sand, silt, and clay and does not change. Soil structure describes how particles are arranged and can be improved or damaged. Pore space controls air and water movement and is essential for root function. Together, these properties determine whether soil supports healthy tree growth. In the next episode, we'll focus specifically on soil water, drainage, and aeration, and explain how too much or too little water affects tree health. Thanks for listening to the Arborist Podcast. Let's keep building your arborist knowledge, one topic at a time. Arborist Podcast, Domain 2, Episode 3, Soil Water, Drainage, and Aeration, How Water and Oxygen Affect Tree Health. Welcome back to the Arborist Podcast. This podcast is designed to help you study for the ISA Arborist Certification Exam by breaking down complex arboriculture topics into clear, practical explanations. As always, this podcast is not affiliated with or endorsed by the International Society of Arboriculture. It's an independent educational resource created to support arborists preparing for the certification exam. In the last episode, we talked about soil texture, structure, and pore space. Today, we're going to build on that foundation by focusing on soil water, drainage, and aeration. These concepts explain why trees suffer in both flooded and drought conditions, and why water management is such a critical arborist skill. Why water and oxygen matter? Roots need both water and oxygen to function. Water is essential for nutrient transport, photosynthesis, and cell function. Oxygen is required for root respiration. When soil holds too much water, oxygen is displaced. When soil holds too little water, roots dry out. Healthy soil balances water and air availability. How water moves through soil. Water moves through soil by gravity and capillary action. Gravitational water drains freely through large soil pores after rainfall or irrigation. Capillary water is held in smaller pores and is the primary source of water available to roots. Water that is held too tightly to soil particles is unavailable to plants. Understanding these distinctions helps explain why some soils stay wet but still cause drought stress. Field capacity and available water. After excess water drains away, soil reaches what is called field capacity. At field capacity, soil holds the maximum amount of water available to plants while still containing sufficient oxygen. This is the ideal moisture condition for root function. If soil remains saturated beyond this point, oxygen levels drop and roots begin to suffer. Soil drainage explained. Drainage refers to how quickly excess water moves out of the soil. Well-drained soils allow gravitational water to move through easily. Poorly drained soils retain water longer and often become saturated. Drainage is influenced by soil texture, structure, compaction, and site conditions such as slope and grading. Poor drainage is one of the most common soil problems affecting trees. Aeration and root respiration. Aeration is the movement of air into and out of soil. Roots require oxygen for respiration, just like above-ground tissues. When soil is compacted or saturated, oxygen movement slows dramatically. Without adequate oxygen, roots cannot absorb nutrients effectively and growth declines. This often leads to symptoms such as leaf chlorosis, dieback, and reduced vigor. Symptoms of poor drainage and aeration. Trees growing in poorly drained or poorly aerated soils often show similar symptoms. These may include slow growth, small leaves, early fall color, or branch dieback. Because these symptoms are nonspecific, soil conditions must be evaluated before assuming nutrient or pest problems. This is a common exam scenario. Urban factors affecting water and aeration. Urban environments frequently disrupt natural soil water movement. Compaction, impervious surfaces, altered drainage patterns, and soil layering all affect water and oxygen availability. Trees planted in urban sites often experience chronic stress related to poor drainage and limited aeration. Understanding these limitations helps arborists recommend realistic solutions. Managing soil water issues. Arborists manage water issues by improving drainage, reducing compaction, and adjusting irrigation practices. Overwatering can be just as harmful as underwatering. Irrigation decisions should be based on soil moisture, not just surface appearance. Proper management supports healthy root function and long-term tree performance. This episode connects directly to previous topics. Soil texture and structure influence pore space. Pore space controls water and oxygen movement. Roots depend on that balance to function. Water, oxygen, and roots are inseparable parts of the soil system. Let's recap the key points. Soil water exists in different forms, and only some of it is available to trees. Proper drainage and aeration are essential for root respiration. Both excess and insufficient water can cause stress, often producing similar symptoms. Understanding soil water and aeration helps arborists diagnose problems and manage trees more effectively. In the next episode, we'll focus on soil compaction, what causes it, and why it is one of the most damaging conditions for urban trees. Thanks for listening to the Arborist Podcast. Let's keep building your arborist knowledge, one topic at a time. Arborist Podcast, Domain 2, Episode 4, Soil Compaction, Causes, Effects, and Why Trees Struggle in Urban Soils. Welcome back to the Arborist Podcast. This podcast is designed to help you study for the ISA Arborist Certification Exam by breaking down complex arboriculture topics into clear, practical explanations. As always, this podcast is not affiliated with or endorsed by the International Society of Arboriculture. It's an independent educational resource created to support arborists preparing for the certification exam. In the last episode, we talked about soil water, drainage, and aeration. Today, we're focusing on soil compaction and why it is one of the most common and damaging soil problems affecting trees, especially in urban environments. What is soil compaction? Soil compaction occurs when soil particles are pressed closer together. As particles move closer, pore space is reduced. This limits the movement of air, water, and roots through the soil. Compaction does not change soil texture, but it severely damages soil structure and pore space. For arborists, this distinction is important. Texture is permanent. Compaction is often caused by human activity. Common causes of soil compaction. Soil compaction is most commonly caused by pressure applied to the soil surface. This includes foot traffic, vehicles, construction equipment, and repeated use of heavy machinery. Urban trees are especially vulnerable because soil is often compacted before trees are even planted. Construction activities around existing trees are a major cause of root damage and long-term decline. How compaction affects soil function. Compaction reduces large pores first. These macropores are responsible for drainage and oxygen movement. As macropores collapse, water infiltration slows and oxygen availability decreases. Soil may stay wet longer, but roots still suffer from oxygen deprivation. This explains why compacted soils can appear moist while trees show drought-like symptoms. Effects of compaction on roots. Roots need space to grow and oxygen to respire. In compacted soil, roots struggle to penetrate dense layers. Growth becomes shallow and restricted. Limited root growth reduces water and nutrient uptake and weakens anchorage. Over time, this leads to reduced vigor, increased stress, and higher failure risk. Above-ground symptoms of compacted soils. Compaction-related stress often shows up in the canopy. Common symptoms include reduced shoot growth, smaller leaves, sparse canopy, early fall color, dieback. These symptoms are nonspecific, which is why soil conditions must always be evaluated during diagnosis. Compaction in urban tree sites. Urban soils are often compacted, layered, and disturbed. Sidewalks, roads, buildings, and utilities limit root space and concentrate traffic pressure. Even well-maintained urban trees often grow in poor soil conditions. Understanding this context helps arborists set realistic expectations and communicate limitations to clients. Preventing soil compaction. Preventing compaction is far easier than fixing it. Protecting root zones during construction, limiting traffic under trees, and establishing tree protection zones are critical practices. Once soil is compacted, recovery is slow and difficult. This is why prevention is emphasized heavily on the ISA exam. Managing compacted soils. When compaction already exists, arborists may recommend practices such as soil aeration, vertical mulching, or organic matter incorporation. These methods aim to increase pore space and improve oxygen and water movement. However, results depend on the severity of compaction and site conditions. Compaction management is often about improvement, not full restoration. This episode ties together multiple soil concepts. Texture influences how soil responds to pressure. Structure and pore space determine how damaging compaction becomes. Water, aeration, and root health are all affected by compaction. Soil compaction is a central cause of many urban tree problems. Let's recap the key points. Soil compaction reduces pore space, limits oxygen and water movement, and restricts root growth. It is commonly caused by human activity and is a major factor in urban tree decline. Preventing compaction is more effective than correcting it after the fact. In the next episode, we'll shift focus to soil organisms and the soil food web and explain how living organisms in the soil support tree health. Thanks for listening to the Arborist Podcast. Let's keep building your arborist knowledge one topic at a time. Arborist Podcast, Domain 2, Episode 5, Soil Organisms and the Soil Food Web, the Living System Beneath Trees. Welcome back to the Arborist Podcast. This podcast is designed to help you study for the ISA Arborist Certification Exam by breaking complex arboriculture topics into clear, practical explanations. As always, this podcast is not affiliated with or endorsed by the International Society of Arboriculture. It's an independent educational resource created to support arborists preparing for the certification exam. In the last episode, we talked about soil compaction and why it is such a major cause of tree stress. Today, we're going to look at a part of soil that's often invisible but incredibly important. Soil is alive. Today's episode is about soil organisms and the soil food web, and how living organisms in the soil support tree health. Soil is a living system. Healthy soil is not just mineral particles, water, and air. It also contains a wide range of living organisms. These organisms interact with each other and with tree roots, forming what is known as the soil food web. The ISA exam expects arborists to understand that soil biology plays a major role in nutrient cycling, structure, and overall soil function. What is the soil food web? The soil food web is a network of organisms that live in the soil and interact through feeding relationships. Energy enters the soil food web primarily through organic matter, such as fallen leaves, dead roots, and other plant material. As this material decomposes, nutrients are released and made available to plants. The soil food web connects decomposition, nutrient cycling, and plant health. Major groups of soil organisms. Soil organisms range from microscopic to visible. Bacteria and fungi are responsible for most decomposition and nutrient transformations. Protozoa and nematodes feed on bacteria and fungi, releasing nutrients in plant-available forms. Larger organisms such as insects, arthropods, and earthworms help mix soil and improve structure. Each group plays a specific role in maintaining healthy soil function. Fungi and their role in soil. Fungi are especially important in tree-dominated systems. They break down complex organic materials that bacteria cannot easily decompose. Many fungi form beneficial relationships with tree roots, known as mycorrhizae. These relationships increase water and nutrient uptake and improve stress tolerance. Understanding fungal relationships is important for arborists working with mature trees. Bacteria and nutrient cycling. Bacteria are highly efficient decomposers of simple organic compounds. They play a key role in converting nutrients into forms that plants can absorb. Bacterial populations respond quickly to changes in soil conditions, moisture, and organic matter. Healthy bacterial activity supports consistent nutrient availability for roots, soil organisms, and soil structure. Soil organisms help create and maintain soil structure. As organisms move through soil and feed on organic matter, they create aggregates and pore space. These aggregates improve aeration, water infiltration, and root penetration. Biological activity helps counteract compaction and improve soil resilience over time. Impact of urban conditions on soil biology. Urban soils often have reduced biological activity. Compaction, low organic matter, pollution, and frequent disturbance limit soil organism populations. This reduces nutrient cycling and weakens soil structure. Trees growing in biologically inactive soils often rely more on stored energy and show reduced vigor. Supporting soil biology as an arborist. Arborists can support soil biology through management practices, adding organic mulch, reducing disturbance, and improving soil conditions all support biological activity. Avoiding unnecessary chemical inputs also helps maintain beneficial organisms. The goal is to create conditions where soil organisms can thrive naturally. This episode connects directly to earlier soil topics. Texture and structure influence habitat for organisms. Pore space allows movement and oxygen. Organic matter fuels biological activity. Soil biology ties physical and chemical soil properties together. Let's recap the key points. Soil is a living system supported by a complex food web of organisms. These organisms decompose organic matter, cycle nutrients, improve soil structure, and support tree health. Healthy soil biology is essential for long-term tree performance. In the next episode, we'll focus on how trees absorb water from the soil and how water moves through trees, connecting soil conditions to tree physiology. Thanks for listening to the Arborist Podcast. Let's keep building your arborist knowledge, one topic at a time. Arborist Podcast, Domain 2, Episode 6, Water Uptake, Movement, and Tree Water Relations, How Trees Use Water. Welcome back to the Arborist Podcast. This podcast is designed to help you study for the ISA Arborist Certification exam by breaking complex arboriculture topics into clear, practical explanations. As always, this podcast is not affiliated with or endorsed by the International Society of Arboriculture. It's an independent educational resource created to support arborists preparing for the certification exam. In the last episode, we talked about soil organisms and the soil food web. Today, we're connecting soil conditions to tree physiology by focusing on how trees absorb water and how that water moves through the tree. Understanding tree-water relations helps explain drought stress, flooding damage, and many canopy symptoms seen on the ISA exam. Why water is critical to trees. Water is essential for nearly every tree function. It is required for photosynthesis, nutrient transport, temperature regulation, and maintaining cell structure. Without adequate water, trees cannot move nutrients, produce energy efficiently, or maintain healthy tissues. This is why water stress, whether from too little or too much water, has such a strong impact on tree health. How roots absorb water. Most water absorption occurs through fine, non-woody roots. These roots are located primarily in the upper layers of soil where oxygen is available. Water enters roots through osmosis, moving from areas of higher water concentration in the soil to lower water concentration inside root cells. Healthy root systems depend on proper soil moisture and aeration to function effectively. The role of root hairs and mycorrhizae. Root hairs greatly increase the surface area available for water absorption. They are short-lived and constantly replaced as roots grow. Mycorrhizal fungi further extend the effective root system by increasing access to water and nutrients beyond the immediate root zone. These relationships improve drought tolerance and overall tree performance. Water movement. Through the tree, once water enters the roots, it moves upward through the xylem. This upward movement is driven primarily by transpiration, the loss of water from leaf surfaces. As water evaporates from leaves, it creates tension that pulls water upward through the tree. This process is often described as the transpiration pull mechanism. Transpiration and environmental factors. Transpiration rates are influenced by environmental conditions. High temperatures, low humidity, wind, and strong sunlight increase transpiration. When water loss exceeds uptake, trees experience water stress. Trees may respond by closing stomata to reduce water loss, but this also limits photosynthesis. This balance is a key exam concept. Water stress and tree response trees respond differently to short-term and long-term water stress. Short-term drought stress may cause wilting or temporary leaf drop. Chronic water stress leads to reduced growth, dieback, and increased susceptibility to pests and disease. Flooded conditions also cause stress by limiting oxygen availability to roots. Both extremes disrupt normal tree function. Hydraulic failure and cavitation. Under severe water stress, air bubbles can form in xylem vessels. This process is called cavitation. Cavitation disrupts water transport and can lead to branch dieback or death of tissues. Some species are more resistant to cavitation than others, influencing drought tolerance. Connecting soil conditions to tree water use. Soil texture, structure, compaction, and drainage all influence water availability. Poor soil conditions limit water uptake even when moisture is present. This explains why irrigation alone may not solve water stress problems. Effective water management requires understanding both soil and tree physiology. Let's recap the key points. Trees absorb water primarily through fine roots and root hairs. Water moves upward through the xylem driven by transpiration. Environmental conditions influence water loss, and both drought and flooding can cause stress. Understanding tree-water relations helps arborists diagnose problems and manage trees more effectively. In the next episode, we'll focus on irrigation principles for trees and explain how arborists can apply water effectively without causing additional stress. Thanks for listening to the Arborist Podcast. Let's keep building your arborist knowledge one topic at a time. Arborist Podcast, Domain 2, Episode 7, Irrigation Principles for Trees, Applying Water Effectively and Responsibly. Welcome back to the Arborist Podcast, and this podcast is designed to help you study for the ISA Arborist Certification exam by breaking down arboriculture topics into clear, practical explanations you can actually use. As always, this podcast is not affiliated with or endorsed by the International Society of Arboriculture. It's an independent educational resource created to support arborists preparing for the certification exam. In the last episode, we talked about how trees absorb and move water through their systems. Today, we're focusing on irrigation and how arborists can apply water in ways that support tree health rather than create additional problems. Irrigation is a common exam topic because improper watering is one of the most frequent causes of tree stress. Why irrigation matters? Irrigation is meant to supplement natural rainfall. It is not about keeping soil constantly wet. It is about providing adequate moisture to support root function without limiting oxygen availability. Many tree problems blamed on drought are actually caused by poor irrigation practices. Understanding irrigation principles helps arborists prevent stress rather than react to symptoms. Trees are not lawns, and one of the most important irrigation concepts is that trees have different water needs than turf grass. Lawns are shallow-rooted and require frequent light watering. Trees have deeper and wider root systems and benefit from slower, deeper watering. Applying lawn-style irrigation to trees often leads to shallow rooting, poor aeration, and long-term stress. This distinction is emphasized on the ISA exam. Where to apply water? Water should be applied over the root zone, not at the trunk. The majority of absorbing roots are located in the upper soil layers and extend outward well beyond the canopy drip line. Focusing water at the base of the trunk does little to benefit the tree and can promote trunk and root collar issues. Effective irrigation targets the area where fine roots are actively growing. How much water is enough? The goal of irrigation is to moisten the soil to an appropriate depth without saturating it. The amount of water needed depends on soil texture, tree size, weather conditions, and site characteristics. Sandy soils require more frequent watering with smaller amounts. Clay soils require slower application and longer intervals between watering. There's no single schedule that works for all trees. Timing and frequency of irrigation. Infrequent deep watering encourages roots to grow deeper and improves drought tolerance. Frequent, shallow watering keeps roots near the surface and increases vulnerability to stress. Irrigation timing should also consider weather conditions. Watering during cooler parts of the day reduces evaporation losses. Monitoring soil moisture is more reliable than relying on fixed schedules. Overwatering and its consequences. Overwatering is just as damaging as underwatering. Excess water fills pore space, displaces oxygen, and limits root respiration. Symptoms of overwatering often resemble drought stress, including wilting and chlorosis. This makes accurate diagnosis especially important on the exam and in the field. Irrigation and newly planted trees. Newly planted trees require special irrigation attention. Because root systems are limited, these trees depend heavily on consistent soil moisture during establishment. However, even young trees need oxygen, and overwatering can slow root development. Gradual reduction of irrigation encourages roots to grow outward into surrounding soil. Irrigation in urban environments. Urban irrigation is often complicated by compacted soils, impervious surfaces, and altered drainage patterns. Runoff, poor infiltration, and uneven moisture distribution are common challenges. Arborists must adapt irrigation strategies to site limitations rather than relying on ideal conditions. Understanding these constraints helps arborists set realistic expectations with clients. This episode connects soil texture, structure, compaction, and tree-water relations. Effective irrigation supports healthy root function only when soil conditions allow water and oxygen movement. Water management is always a balance. Let's recap the key points. Trees benefit from deep and frequent watering that targets the root zone. Overwatering and improper placement are common causes of stress. Irrigation decisions should be based on soil conditions, not assumptions. In the next episode, we'll wrap up Domain 2 by focusing on managing soil problems in urban environments and applying everything we've learned so far. Thanks for listening to the Arborist Podcast. Let's keep building your arborist knowledge one topic at a time. Arborist Podcast, Domain 2, Episode 8. Managing soil problems in urban environments, applying soil knowledge in the real world. Welcome back to the Arborist Podcast. This podcast is designed to help you study for the ISA Arborist Certification exam by breaking down arboriculture topics into clear, practical explanations. As always, this podcast is not affiliated with or endorsed by the International Society of Arboriculture. It's an independent educational resource created to support arborists preparing for the certification exam. In this final episode of Domain 2, we're bringing everything together by focusing on how arborists manage soil problems in urban environments. Urban soil conditions are rarely ideal, and understanding how to work within those limitations is a critical arborist skill. Why urban soils are so challenging? Urban soils are often heavily disturbed before trees are planted. Construction, grading, traffic, and utility work commonly compact soil, remove organic matter, and disrupt natural layering. Many urban soils are layered, meaning different soil materials have been placed on top of each other, restricting drainage and root movement. These conditions create long-term stress for trees and limit their ability to grow and recover. Common urban soil problems. Some of the most common soil problems arborists encounter include compaction that limits pore space and oxygen availability, poor drainage that leads to saturated soils, limited root volume due to sidewalks, roads, and buildings, low organic matter, and reduced biological activity, altered water flow caused by impervious surfaces. These problems often occur together, compounding their effects on tree health. Diagnosing soil problems correctly. Effective management begins with proper diagnosis. Arborists should evaluate soil texture, compaction, drainage, moisture levels, and root space before making recommendations. Above-ground symptoms alone are not enough. Small leaves, dieback, and poor growth often point to below-ground limitations rather than pests or nutrient deficiencies. This diagnostic mindset is heavily emphasized on the ISA exam. Setting realistic expectations. One of the most important roles of an arborist is communication. In many urban sites, soil conditions cannot be fully corrected. Arborists must explain limitations clearly and set realistic expectations about growth, longevity, and maintenance needs. Improvement is often the goal, not perfection. Improving soil conditions where possible. When conditions allow, arborists may recommend practices to improve soil function. These may include reducing compaction, increasing organic matter, and improving drainage or aeration. Mulching is one of the most effective and practical tools for supporting soil health. Organic mulch moderates soil temperature, conserves moisture, and supports soil biology over time. Protecting existing soil and roots. Protecting soil is often more effective than attempting to fix it later. Tree protection zones, limiting traffic, and careful planning during construction help preserve soil structure and root function. Preventative measures are emphasized heavily in professional arboriculture and on the ISA exam. Species selection and site matching. In challenging soil conditions, species selection becomes especially important. Some tree species tolerate compacted, poorly drained, or limited soils better than others. Matching species to site conditions improves survival and reduces long-term management issues. This concept connects soil science directly to tree selection and planning, integrating soil knowledge into arborist practice. Managing urban soil problems requires an integrated approach. Soil texture, structure, water movement, compaction, biology, and tree physiology all interact. Successful arborists evaluate the entire system rather than focusing on a single factor. This systems-based thinking is exactly what the ISA exam is testing. Domain 2 is about understanding the environment roots grow in. Soil properties influence water availability, oxygen movement, nutrient cycling, and root health. Every tree problem has a soil component, whether obvious or hidden. Arborists who understand soils make better diagnoses and better decisions. Let's recap the key points. Urban soils are often compacted, disturbed, and biologically limited. Arborists must diagnose soil problems accurately, set realistic expectations, and focus on improvement and protection where possible. Managing soil conditions is essential to long-term tree health and success. That completes Domain 2, Soils and Water. You now have a strong foundation for understanding how soil conditions affect tree health and why below-ground factors are so critical. In the next domain, we'll shift our focus to tree nutrition and fertilization and explain how nutrients interact with soil and tree biology. Thanks for listening to the Arborist Podcast. Let's keep building your arborist knowledge, one domain at a time.